Hi all, welcome to Process Before Equations. And today the topic of discussion is polytropic efficiency or polytropic compression. Let's start with a very simple example. Imagine we have a piston filled with gas. When we push the piston inward, the gas gets compressed. Three things happen during compression. Your volume decreases, pressure increases, and temperature also increases. Now, how exactly the pressure and temperature change depends on heat transfer during compression. There are main three types of compression processes. First is isothermal compression, where the temperature remains constant. This happens if heat continuously leaves the gas during compression. Second is adiabatic compression, where no heat leaves the gas. All the work done on the gas increases its temperature. But in real compressors used in industry, the process is neither perfectly isothermal nor perfectly adiabatic. There is some heat transfer, but not completely. There are also losses due to friction and turbulence. Because of this, real compressors follow a more general process called polytropic compression. So, polytropic compression basically represents the realistic behavior of gases in actual compressors. Now, let's understand what polytropic compression actually means mathematically. Engineers describe this process using the equation PV to the power n is equal to constant. Here P is pressure, V is volume, and n is called the polytropic exponent. The value of n tells us how the gas behaves during compression. For example, if n is equal to 1, the process becomes isothermal compression. If n equals gamma, which is the ratio of specific heat, Cp by Cv, the process becomes adiabatic compression. But in real compressors, the value of n usually lies between 1 and gamma. This means the process lies between isothermal and adiabatic compression, and that is exactly what we call polytropic compression. Now, engineers also talk about polytropic efficiency. Polytropic efficiency simply measures how efficiently a real compressor performs compared to an ideal polytropic compression process. In reality, compressors require more work because of friction, heat loss, and mechanical inefficiencies. So, polytropic efficiency tells us how close the real compressor is to the ideal behavior. This concept is widely used in industries such as oil and gas, chemical plants, power plants, and compressor design, and it is also used in simulation tools like Aspen HYSYS. That's it for polytropic compression and polytropic efficiency. Thank you all.